Hello friends, welcome back in the next video of Hackerrank interview preparation kit. Today we will solve the next problem of week 1, lonely integer. Here we have given an array where every element occurs twice except one. We will call that element the lonely integer. For example, look at this array 1, 2, 3, 4, 3 to 1. Here only 4 is not occurring twice. So 4 is lonely integer. In constants, they says it is guaranteed that n is an odd number and there is one unique element. Obviously, if every element has a pair and only one element does not have a pair, then the number of elements will be odd. Question is simple. We will solve this question with three approaches. Don't skip any part because every approach to solve question will help you to build your problem solving skill. I will try to make this video short by skipping code typing part. We will solve it by brute force approach, then build up to the efficient logic. In brute force approach, we have to understand two test cases in which we can find lonely integer. In first example, we have array of length 7. Elements of array are 2, 5, 1, 5, 3, 2, 1. Array size is small, so you can easily identify that 3 is lonely integer and other element have pair. But how the computer will find it? For that, we will write code like first sort this array, then we will get this array in format where elements have pair next to each other. So we will iterate this array and check if ith element have same element at the next index. For this, we have to shift second index element after comparison of 0th index element and first index element, and it will be continue. When it will find ith element and I plus 1th element is not same, then ith element is the lonely integer like 3. But if we made a for loop range from 0th index to last index, then it will compare last element with its next element and then we will get array out of bound exception. Because there is no next element to compare after last element, for this we will do one thing. We will iterate this array till length minus 2 index because last index is length minus 1 and we have to iterate till only last minus 1th index. This example is for only if element is present in 0 to last minus 1 index. Here is second example where after sorting that element is at last index, but in for loop we are not able to scan last element. So if we know there is definitely one unique element in array and if it is not present in range 0 to last minus 1, then definitely it is present in the last index. I hope you understood the logic. So this is the code for this logic. We can clear all test cases with this code, but this is not efficient because it uses more time and space. For that we have second approach. In this we will use set data structure. We know in set duplicates are not allowed and we will use this property. We will start to insert list element in hash set. In that for loop we will make condition like if ith element is already present, then remove from hash set, else add I element in hash set. So here imagine we are running for loop. It will add 2, 5, 1 because till now they are not present in the hash set. Then next it will check 5. This 5 is already present, so it will remove from the hash set. Then same for other elements. Finally 3 will remain in the hash set. By this way we got lonely integer. Let's see how can we implement this logic. Here we created empty hash set, then using for each loop we check if hash set already have that element in it, then just remove from it, else add in it. We can't return hash set element directly using index and it's containing only one element, so we will return that hash set using for each loop. If we run this, we are getting error like missing return statement. It is because compiler is thinking like if in case hash set is null, so we have to write one more return statement which will not execute, but it will help us to avoid error. Now all test cases are passing. In this solution, we reduce time complexity. But what about space? We can make this code more efficient by our third approach, which is very short to implement. For this, we have to use XOR operator. XOR stands for exclusive OR. XOR is bitwise operator. We use it in bits manipulation. We will not go in depth of bits manipulation. To solve this question, you should know only these 2 points. First is XOR between same number is 0. Then second is any number XOR 0 is number itself. So if we do XOR operation in loop, it will look like this. Here same element will become 0 because of our first point, and then this will remain. After this operation 3 will remain because of second point. I suggest you to learn about bit manipulation if you do not have that much idea about it, because it will be helpful to solve more questions like this. This is the implementation of that logic. It is more efficient than before one. All test cases are passed. I hope you understood every approach clearly, but still if you have any doubt then comment below. Thank you.